There is a wide phenomenon that many people know as Northern Lights. Northern Lights have to appear like lights in the sky. They tend to be the North Pole, that's why Northern Lights. It can be in North Pole, in Alaska, and some other places of the world. For years, people thought they were magical, that they were their ancestors' spirits or some stuff. It's natural to think about that when it's something you cannot explain. Well, now it's the 21st century and Northern Lights can be explained with physics. So what are the Northern Lights? The Northern Lights are bright dancing lights of the aurora that are actually collisions between electrical charged particles from the sun that enter the Earth's atmosphere. The lights are seen above the magnetic poles of the northern and southern hemispheres. They are known as aurora borealis in the north and aurora australis in the south. Aurora displays appear in many colors, although pale green and pink are the most common. Shades of red, yellow, green, blue, and violet have been reported. The lights appear in many forms, from patches or scattered clouds of light to streamers, arcs, rippling curtains, or shooting rays that light up the sky with an airy glow. These lights happen because the Northern Lights are actually the results of collisions between gaseous particles in the Earth's atmosphere, with charged particles released from the Sun's atmosphere. Variations in color are due to the type of gas particles that are colliding. The most common aurora color, a pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. Rare, all-red auroras are produced high-altitude oxygen at heights of up to 200 miles. Nitrogen produces a blue or purplish-red aurora. The connection between the Northern Lights and the sunspot activity has been suspected since about 1880. Thanks to research conducted since 1950s, we know that electrons and protons from the sun are blown towards the Earth and the solar wind. The temperature above the surface of the sun is millions of degrees Celsius. At this temperature, collisions between gas molecules are frequently explosive. Free electrons and protons are thrown from the sun's atmosphere by rotation of the sun and escape through holes in the magnetic field. Blown towards the Earth in the solar wind, the charged particles are largely deflected by the Earth's magnetic field. However, the Earth's magnetic field particles is weaker at either pole, and therefore some particles enter the Earth's atmosphere and collide with gas particles. These collisions emit light that we perceive as dancing light in north and south. The lights of the aurora generally extend from 80 kilometers to as high as 640 kilometers above the Earth's surface.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. And after 18 hours, the solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.
Now, this thing that happens to the sun that launches its particles and goes through the deflection magnetic field on the Earth, it's an 11-year cycle, which means it takes 11 years for the sun to create that peak of energy that then is launched towards the Earth and deflected by its magnetic field. When it's most active, the sun maximum, there are some sunspots present in it, and they'll flash, releasing the powerful burst of energy into space, as well as sprays of hot ionized gases or plasma that scientists call the solar wind. In theory, this should lead to bigger and brighter displays. However, it's not quite that clear-cut. At the moment, there is known that the most bright and intense peak has been for almost 50 years in development on the sun. That those things are things that like hits the Earth and they're deflected by magnetic field, and when they're deflected, the electrons and protons collide with the gases in the Earth, and that's why we see those lights. That's what produces the aurora boreal. There are two large shifting ovals of aurora activity around the geomagnetic poles. One in the northern hemisphere, the other in the southern hemisphere, where the solar lights of aurora or aurora australis can be seen. During the solar minimum, what you get is aurora argentacted aurora oval. This is not a place you imagine to be. Well, the only reason that this happens on the north and south poles is because of the magnetic field of the Earth. when you see a compass that points north, it happens because it follows the magnetism, the magnetic field of the North Pole. This means that the Earth is charged positive and negative as any other body in existence in the world. This means that the magnetic field goes from north to south, meaning that when the solar burst runs into the Earth, it may hit north, it may hit the south, it depends on the Earth's position, but when it hits it, it travels all around the globe to the other pole and then it's released to the outer space, which means that all this energy is not conserved by the Earth. The Earth is just like a conductor. And well, in that transition, the only points where the aurora touches the Earth are the north and the south, and we're all not that exact points, some others which have high electromagnetism points, meaning that these are the only parts of the Earth that can be seen in the aurora boreal, because they are the only parts that the gases collide with the electrons and protons because of the travel of the magnetic wave. There are some sayings that these solar flares can affect some electrical devices on Earth. Well, obviously, because it's the flares of the sun, they're electrically charged. That's why the magnetic field prevents them from touching all other parts of the Earth other than the poles. When they hit the poles, they travel around stuff, right? But there's this doubt that this magnetic field collision can cause some negative repercussions to some electrical devices on Earth, like satellites, like aircraft, like radio signals and stuff. So here's the doubt that somebody called Andrew C. that asked aircraft captain called Captain Lee about these things, this doubts he has about if the aurora and the northern lights have an effect or a threat against aircraft safety. Well, the response to this Andrew by Captain Lim, well, he explains first what is the aurora boreal and stuff, all that we know about aurora boreal so far. And when I quote in here, he says, "So, aside from the distraction caused by the pilots, does the aurora pose hazard of flying?" Well, there were talks about that. It does affect radio reception. How? During the solar flares, our incoming charged particles and stream down along the direction of the Earth's magnetic field to affect the ionosphere that both absorb and reflect radio waves. This has the effect on interfering with radio propagation in places like Alaska and other polar regions at lower latitudes. Sometimes these aurora effects lead to weird and wondrous paths where people in Alaska can listen to AM radio from China or South America. Or Fairbanks can drivers receive instructions from dispatchers from New York. This was probably caused by the radio waves bouncing several times between the ionosphere and the Earth's surface before reaching the destination. Surprisingly, on the night when we encountered the aurora as we flew across the Atlantic, our high frequency radio reception with Shannon and Render stations was crystal clear when compared to nightmares we used to experience over the Bay of Bengal with Mumbai, Madras, or the Calcutta radio stations. Those aurora's effects on the weather, researchers have found that the storms beginning on the North Pacific during the times of major auroral displacement tend to grow more than did some storms begin at other times. It's also known that the aurora process affects both electric fields and air temperatures high above the ground, and those changes could reach down into weather systems. According to Dr. Neil Davis, a seismologist at the Geological Institute, University of Alaska, Fairbanks, the effects of aurora energy are relatively minor when compared to those driving primarily weather processes. Well, now we know some other stuff that we need to know. Some negative repercussions. Well, not that negative. They're just repercussions from the aurora borealis. What's this? That the radio waves travel from one radio station to the satellites and then to the other stations, like radios on the whole globe. Some of them are deflected by the magnetic field, by the collisions of the magnetic field between the particles of the sun and the gases of the earth, causing that you can listen to some radio stations that are not from your country. Like in China, they can hear New York radio stations that aren't meant to be heard there. Or they can also improve radio reception when having contact with other radio stations. They can improve it by the same, because that travel makes better the radio reception. And there's also this theory that it affects weather. Okay, as I said, the only parts that this happens is when you can see the aurora borealis, which is when the actual collision between these particles and the gases happens, because it's the only place that happens the deflection of the electromagnetic field. You go from north or south and go to the other pole without touching any other part of the globe. All that zone from the north and south gets touched with this electromagnetic field happening, and then the deflection happens, going from north to south. The aurora borealis is a beautiful show to watch, a beautiful natural show that has existed since the existence of the Earth. Well, the existence of the electromagnetic field surrounding the Earth, and the solar flares. Almost even since the man started to write, even then history started. These lights obviously started with legends, because in some other times before, people couldn't. The only way they could explain some things that couldn't be explained, that it can be explained now, is with mysticism and magic. Here's some legends about the aurora borealis, and with this we will finish. These lights in the northern hemisphere have a Roman myth. The aurora was the goddess of the dawn. Many cultural groups have legends about the lights. In medieval times, the occurrence of auroral displays were seen as harbingers or war of famine. The Maori of the New Zealand share belief with many northern people of Europe and North America that the lights were reflections from torches or campfires. The Menominee Indians in Wisconsin believe that the lights indicate the location of Manabiwok, giants, who were the spirits of great hunters and fishermen. The Inuit of Alaska believe that the lights were the spirits of the animals they hunted, the seals, salmon, deer, and beluga whales. Other Aboriginal peoples believe that the lights were the spirits of their people.